Compared to the rest of the animal kingdom, human beings are actually kind of weak. A chimp is 4 times stronger than you, while an ant can lift 50 times its own weight. So how, as humans, did we go on to build all these huge and amazing structures that you see around you every day? Well, we kind of cheated, using physics and some really simple tools. We get into all about simple machines right now. Simple machines are the building blocks of all technology, which is a little bit funny because they don't have batteries or computers at all. They are completely unplugged. They are simple tools which can give you superhuman strength by doing one of 2 things. They either change the amount of force needed for a job or change the direction of the force entirely. In this video, we are going to go over 6 simple machines and how they work. Let's go! Don't sue me, Nintendo. I'm just trying to make a fun video for kids to learn, so back off. First up, we have the lever. The lever is a stiff bar or plank that rests on top of a pivot point, known as a fulcrum. The secret here is distance. By pushing down on a long bar far away from the fulcrum, you multiply your strength, changing the amount of force needed to lift heavy objects. But what happens if you move the fulcrum? The closer you slide the fulcrum to the heavy object, the less force is needed to move that object. You could lift a bowling ball with just 1 finger if the fulcrum is close enough to the bowling ball and the plank is long enough. If the fulcrum is in the middle, that results in balance. The seesaw is a great example of this. A wheelbarrow is another really good example of a lever. The front wheel is the fulcrum. So when you lift with the wooden handles all the way at the other end, you can lift hundreds of pounds of rocks, dirt, or whatever way more easily. Next up, we have the inclined plane, which is just a fancy word for ramp. So fancy! What a ramp does is it spreads out the amount of force needed over a longer distance. Instead of trying to lift a 200-pound bag straight up and hurting your back, a ramp spreads out the work over a longer distance. You use less force over a longer distance, but still get the job done. If you've ever moved or seen somebody load or unload a heavy truck, they are always using a ramp because it spreads out the amount of force needed, so they don't hurt themselves trying to lift heavy things all at once. Dump trucks and slides are also examples of inclined planes. However, instead of trying to move things up, they work in reverse, using the power of gravity to help move things down. Okay, now what if we take 2 ramps and put them back to back? Now we have our next simple machine, the wedge. Instead of moving things up, a wedge drives into things, changing the direction of the force. Push a wedge down and it pushes out, splitting things apart. There are a lot of good examples of wedges. An axe is a really good one. You swing it down and it splits the wood, pushing it out. When somebody was cooking slices a piece of meat, the knife is the wedge. It moves down and pushes the meat apart. Next up, we have a screw. And believe it or not, a screw is actually just an inclined plane wrapped around a cylinder. Now, most people know that screws are used to secure, tighten, or attach things, but there are other uses for it as well. The spiral ridges on a screw are called the threads, and they act as a continuous ramp wrapped around the entire screw. Because the mini ramp or thread is wrapped around the screw multiple times, it decreases the amount of force you need to either insert the screw or lift something heavy. Twisting the screw rotates the inclined plane, which moves the screw deeper into an object or moves a heavy object up its threads. When you twist a screw around in a circle, it changes your spinning motion into a straight line. It pulls itself straight down into the wood or other material with giant, unstoppable force. Next up, we have the wheel and axle. Now, an axle is the rod that is attached to the middle of the wheel. Now, in our world, you see wheels and axles all the time. They're on cars, planes, anything with transportation, even toys. They are a very important simple machine for transportation and movement. There are also other examples all around us, like doorknobs or fidget spinners. It's a very, very important simple machine and used in a ton of things. And this simple machine plays a trick with distance to change the amount of force that you need. The wheel is a lot larger than the axle, so when the wheel is turned, the rod spins really, really fast, multiplying the force. Our last simple machine is the pulley, which is a wheel with a groove and a rope running through it. Pulleys are the ultimate masters of changing the direction of a force. Now, you could try to lift something heavy straight up and fight gravity, which is never a good idea, or you could loop a rope around that wheel and pull down. Now your body weight and gravity work with you to bring that object up. Flagpoles are a great example of pulleys you see all the time. So are window blinds. Construction cranes are actually just a complicated system of pulleys linked together. So pulleys are the masters of changing the direction of a force. We pull down to move things up. All right, friends, that's all the time we have for today. Remember, simple machines are everywhere, and they are absolutely amazing. They help us build all the amazing things that you see around you. Remember that they either change the amount of force needed or change the direction of the force entirely. Take a look right now around your classroom. I bet you could find 3 simple machines hard at work. Give it a try.